So welcome back. Happy Monday. Just a couple of announcements before we jump into the math stuff. So first of all, the homework assignment that you guys, many of you just showed me, was on page 21. And I made a mistake. And so at least one person did more than they needed to do because it says do 1 to 13 and this person did 1 to 13. I intended to just assign the odds. So if you didn't do this yet and you're going to make it up and show it to me next class, just the odds. Same thing on the other part of the assignment, 1 through 9. Odds. However, the packet part of the assignment, which is right there, says all, so do all of those. But the textbook ones, I typically assign only the odds because those are the ones with the answers in the back so you can check. All right? Thank you for catching that. Next, so we begin a couple of pages away from there. So it's down here on page 23, that's where we start. But first we'll take our look at the calendar. And today we're going to talk about radicals and products of binomials. It doesn't quite say it on my screen here, but that's those are the topics for today. The next two classes, Wednesday and Friday, are about factoring, and then Monday, 1 week from today, is the quest number 3. The quest does not include anything about factoring. So even though the quest is not happening for a week, as soon as we're done with the material for today, that's the end of the new material for the quest. All right? Okay, any questions on the calendar? Okay, one more announcement here. There's going to be a problem-solving forum called Salvaging the Semester. It's happening this coming Wednesday right before our class, so this will be the only reminder I can give you because when we see each other next, it will have just passed. But if this class is not going as well as you'd have hoped, or some other classes, or all of your classes, it is not too late to salvage the semester. And so this would be a good opportunity to just kind of brainstorm about techniques that folks have found success with. Ben?
Is this just math or
every class? Yeah, this is just open to all GCC. It's coming up this Wednesday, right before our class, 12 to 12:50 in the core 208. Lunch is provided. I know this particular forum has happened several semesters in a row now, and I've heard good things about it. So if you have questions, there's contact info there, but just pop by and grab some food and maybe learn some stuff and get some techniques you can try. Any questions on that? Okay, and then one other announcement, what's happening tomorrow? Advising day. Raise your hand if you are coming in tomorrow. 1, 2, 3, 4, 5, 6, 7, 8.5. That's actually not bad. So again, would be great if you have some time to come in and register for classes. You will have your choice of classes if you register tomorrow. But I know some people wait until like the day or 2 days before the semester starts, when it's very difficult to come up with a schedule, especially if you have a lot of external constraints. But in addition to registering, again, there's a paper copy of the schedule of stuff for advising day right across the hall here. There's free food at lunch, there's free massages during the day, so lots of reasons to come. There's a full slate of activities and workshops, so info is over there. Okay. So today we're going to do things a little bit differently. We've got a couple of topics that we're going to cover today, and they're kind of unrelated, which is a little bit strange. But the first set of problems that we're going to skip over, and you guys are going to work on in your groups in just a few minutes, are simplifying radicals. And so, okay, sure, square root of 75 is not a nice number, but remember there is a nice number that you can put into 75. What perfect square goes evenly into 75 is 25. And so you guys do have the list of perfect squares on your first page. We also now have a list of perfect squares on our wall. Here they are in yellow, bottom row. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So when we're thinking about finding a number that goes into 75, the only candidates that we care about are the ones on the yellow in the bottom, right? And so we find 25, and so we say, okay, it's 25 times, and then 3. Just have to fill in whatever's left over. And then our nice property of radicals says you can split up a product. Products are really nice, so are quotients, division. Sums and differences, can't do anything with. And then 25 comes out of the square root as 5. And even if you don't know that, I expect you know that one, but maybe some bigger ones you don't know. How can you see the answer to square root of 25 here in yellow? Just look above. Square root of 25 is 5. Okay, so this is 5 times radical 3, and that's the answer, and it's simplified. So we're done with that one. And we'll do one more together, this number 57 right here. So again, you're only looking for numbers in the bottom row here in yellow that go into 57. That's all we care about. So the first number that's worth anything is 4. We can skip over the 1. Does 4 go into 57? Clearly no, because 4 is even and 57 is not, right? So we can skip that. How about 9? Does 9 go into 57? The answer is no. 9 goes into 54, which is the closest one there, so that's no good. 16, again, it's even. There's no, if 4 doesn't go in, then 16 definitely doesn't go in. 25 into 57? No. 36 into 57? No. And in fact, we're already done. As soon as we get past, like as soon as you're past halfway, you're not going to find anything, right? I mean, like definitely 49 doesn't go into 57. So none of the useful numbers goes into 57. So what does that mean about the square root of 57? You can't simplify it. And that's okay. CBS. Cannot be simplified. Okay, yes.
What is the difference between saying radical or saying square root?
They're both the same thing. The square root is a very particular kind of radical, like this is also technically a radical, but I would never read this symbol as radical 8 because radical is reserved for square root. So this is a certain kind of radical, but I wouldn't call it radical 8. I would say the cube root of 8. Yeah, but for us, square root and radical are the same. Good question. Okay, there's a lot of stuff we're going to do as a group here, but let's skip down to something that we haven't seen before. And it's here in number 4. And it says we will soon cover something called the quadratic formula. There she is in all her glory. Raise your hand if you've seen the quadratic formula before. Looks like just about all of us. Raise your hand if you think you have the quadratic formula memorized already. Not as many, but we still got it. That's okay. So we're going to see that soon, and we're going to end up with crazy complicated expressions like this one right here when we use this quadratic formula. So don't worry about the formula, but I'm just trying to motivate that we're going to use this soon enough, and we're going to get things like that. And the idea here is that this is not simplified, and we're going to need some technique to simplify it. So how about we learn how to simplify this guy right now, and then when we figure out what's going on with this, we'll already be in a position to simplify the answer when we get there. So this one's already written all the way out for us. So the first thing to do is take that 128 and see if we can reduce it just like we did before. So immediately you should be looking up at those yellow numbers. You're looking for a number that goes into 128. Now it happens that 4 goes into 128, and that's fine. But you want to be greedy when you're picking. You want to pick the biggest number that you can that goes in.
So this is like 2, right?
These are the squares. Those are the perfect squares. Yeah. Can anybody find a bigger number that goes into 128? 64 goes in. 64 goes into 128. And you can use your calculator to help you if the numbers get big. So then you can see that 128 has gotten rewritten here as 64 times 2. Yes? And then once we do that, we know that you can split the radical up, and the 64 comes outside and becomes 8. So there's the 8 outside. The 2 is still inside. So now we're down to this guy right here. And we can't simplify the radical anymore, so we're done with that part of the technique. But one thing we can do is split the fraction up into 2 different pieces. There's a negative 16 over 8, that's the first piece, and then there's an 8 radical 2 over 8. And again, that's kind of the weird direction that most people never go, but if I gave you, what could I give you? If I give you 3 halves plus 7 halves, what does that really equal to? It's really 10 halves, right? So I'm going to write it naively as this, yes? And that's how we get 10 halves. So if we believe that this is true, when you have the same denominator, you can just merge them together and make one fraction, well, then we better be able to say that the other direction is true as well. You could split it. If you have 3 plus 7 over 2, that's really the same as 3 over 2 plus 7 over 2. Just going that way. So the 2 things that I see here are a minus 16 over 8, which is this guy, and then separately an 8 radical 2 over 8, which is this guy. You see the 2 pieces? Just split it up. And the single denominator of 8 just gets copied twice, just like it did up here with the halves. And now that it's split into two pieces, you can simplify each one separately. How much is negative 16 over 8? Is negative 2. So there it is. And then what happens to the 8's in the second fraction? They cancel, and we just get radical 2. The negative 2, the plus or minus symbol has been copied from the beginning. It was just there the whole time. And then we get radical 2 at the end. Yeah, Melanie. Mm-hmm. You'd have a plus and a minus, two different answers. Yeah, you can't go any further with the square root of 2. Otherwise, yeah, you're right. You have two really like final answers with no radicals. Good. Okay, so that's that. And on the very next page, there are a bunch of problems you're going to practice on. There's an answer key. And the last topic for today, I said we were going to do things a little bit differently today. So I'm about to finish all the stuff that I'm going to say the entire period. You guys are just going to practice 3 different things. We've already seen 2 of them. Here's the third one. Third one is about multiplying and factoring binomials. Binomial, what does the word bi prefix, what does that mean? 2. So binomial is something like that. A plus B, 2 things added together or subtracted, it's okay. So then this x plus 2 is a binomial, right? 2 terms, x, 2. And x plus 3 is another binomial. And multiplying binomials is something that's going to be very important for us. And I think you guys have a lot of practice this if you took our 105 class, the introductory algebra class. You did a lot of multiplying binomials. So there are 2 things that I can remind you of, 2 techniques for multiplying binomials. One of them was a 4-letter acronym that you might have learned in high school, FOIL. FOIL. And so FOIL stands for first, yeah, outside or outers, inners or inside, and then last. And so we're going to try foiling this thing. The answer is actually already written there, but let's pretend it's not. So we go x plus 2 times x plus 3. Okay, the first thing in each one, I'm going to put a little f right on top. You guys agree that those x are both the first things in each parentheses? So we're going to multiply those first things together. What do we get? X squared. X times x is x squared. Then we are going to look at the outers, the ones that are furthest away from the middle. So I'm going to underline the outers here in purple. Those are the ones that are on the edges on either side. And we're going to multiply those, and what do we get? 3x. And then we'll go to green for the inners. Here I'm going to put a little curve on top of the inner ones. So these are the ones that are as close to the center as possible, and we multiply those, and we get 2x. And then the last, let's go blue. So the last, I'll put a little L underneath the last, but the last thing in each set of parentheses, 2 and 3, multiply 6. First, outers, inners, last. FOIL. What did we do every time? Multiply, right? Then what do you do with these things that you've already got in front of you now? As we combine terms, what's the operation here? It's not multiplication anymore. It's addition. That's right. Yeah, and we'll still call it addition. Yeah. So all of this is multiplication. And then when you get down to here, it's addition. So when we write our answer down here, x squared plus, and then we'll combine terms, 3x plus 2x, 5x, plus, and then the last one, 6. X squared plus 5x plus 6 is over here. All right, so that's FOIL. I'm assuming that we've seen some version of that before. to be honest, I hate FOIL, and if there's one thing I could take out of the high school math curriculum, it would be FOIL, because FOIL is only good when it looks exactly like a binomial times a binomial. And if I change this one and I made it x squared plus x plus 2, FOIL is useless. But if you understand what's happening as opposed to memorizing a silly acronym, then you can multiply anything times anything. So I'm going to share with you something that one of my colleagues does. Her name is Sandy. Anybody remember yeah, it has to do with an animal and water. Right, it's the lobster claws, right? Or the crab. Right. So the idea here is you are multiplying everybody in the first parentheses by everybody in the second. I'll put a quick example here. You know that you're supposed to distribute that, right? 3 times x, 3 times negative 2. That's what you do. Well, you still distribute it even if it was inside of something else, but you distribute everybody. You distribute the 3 like you would have before, but you also distribute the x. So what we're going to do is connect every term in the first parentheses to everyone in the second. This x hits the x. This x also hits the 3. This 2 hits the x, and this 2 hits the 3. And so you can kind of see like a lobster claw there, okay? And so when I do the x times the x, what do I get? X squared, that's the first thing we wrote down. When we do the x times the 3, we get the 3x, we wrote that. 2 times the x, 2x, 2 times 3, 6, right? And the reason I think lobster claw is better than FOIL is that you could then handle this guy. It's just everybody times everybody. This x squared hits the x and the 3. This x right here hits the x and the 3. This 2 hits the x, and it's kind of like a double claw. It's like a 3D, like one of the claws is behind the other one. But yeah, like a chicken, right. Okay, so here is the plan for today. You are going to do pretty much this entire thing in your groups. So what I'd like you to do is go back to this page right here. You're starting at the bottom of page 23. And you're going to try to go all the way past the lobster claw stuff that we just did. And this thing finishes. This finishes on page 27. So this is your goal. And if you finish this stuff, then there's some problems at the top of page 23. Right. So it's all up here. So let's see how far we can get. I will walk around, but work with each other. Check against the answer key as well. Let's see how far we can get.